In this video, we are going to look at some one-sided limits. So you'll notice in this first example, we're being asked to evaluate a limit as the variable t approaches 8, and then that little plus sign there means from the right side. So if you think about a number or a number line, and you think about values that are to the right of 8, the first thing you probably think of is the value 9, because that would be the next whole number. But we don't always want to just look at whole numbers. We want to look at values that are very close to 8. So when you're filling out a table, you probably want to look at things like 8.1, and then get even smaller and closer to 8. So we could look at 8.01, and then even smaller and closer again, 8.001. And so using a calculator, we'll simply plug those values into our function, which is right here. And so you'll notice that when I plugged in just the regular 9, that I got a value of, my y value is negative 359. And then when I plugged in my 8.1, which I did here, you'll notice that my y value was negative 323.99, and they're asking us to go to the nearest thousand, so that'll be 3 decimal places. And then when I plugged in 8.01, you'll notice that my y value is at negative 320. And then when I go to 3 decimal places, that 9 is going to round that one up to a 0, which will round that one up to a 0. So it's going to round up to a 400 to the nearest thousand. And then finally, when I plugged in 8.001, again, looking at 3 decimals, the 9 is going to round that 39 up to a 40, so we're at negative 320.040. So you'll notice what's happening is, as I'm getting closer and closer to the 8 here, you'll notice that these values, we're going from negative 320.4 to negative 320.04. So what we're saying is that they are getting closer and closer to a y value that would just be negative 320. So that would be that one-sided limit. Now, we can also do the same thing looking at a graph. So in this particular example, they are asking me to evaluate the limit as x approaches 2. And again, the plus sign means from the right side. So first find your value of, it's negative 2. Find your value of negative 2 on the x-axis, and then you got to make sure you come in from the correct side. So if we're looking to the right side, that means that we're coming in this direction as we get closer and closer to negative 2. So where is that y value? Even if it doesn't exist, the limit just means what is it getting closer and closer to. And you can see that that value is getting closer and closer to a y value of 3. Now, if we use the same thing, but this time we come in, we're looking at x approaching negative 2 from the left side. So notice when they put a minus here, that is indicating that you are looking from the left side. So as I come in from the left side, coming into negative 2, and I look at where I am on the graph, you'll notice the point is up here at a y value of 5. So the limit of this function approaching negative 2 from the left side, we would say has a value of 5. Now, anytime those limits are not the same, so if we want to look at overall, what is the limit as x approaches negative 2 of the function f of x that's in this graph? If you approach negative 2 from the right side and you have one answer, which was 3, and then you approach it from the left side and you have a different answer, then the overall limit, we say, does not exist. You've got to be able to meet at the same y value for a limit to exist from both sides. Now, just to do some more examples with this same graph, let's go ahead and take an x value of 1. So if we look at this particular graph and we say, what is the limit as x approaches 1? And let's go from the left side first this time of our function. So as I'm coming in from the left side of the graph, you'll notice that I've got part of the graph that, well, you're coming from the left side, so you got to follow the graph. And so this particular part of the graph has a y value of -2. So that would be the limit from the left side. Whereas if I'm looking at the limit as x approaches 1 from the right-hand side, again, follow the graph. I'd pretend like it's a road and I'm walking from the right side. Well, I'm going to end up at, this time, a value of -1. So once again, the overall limit as x approaches 1 does not exist because these two values are different. All right, so now let's look at 4. Let me change colors here. So if we look at 4, if we are looking at the limit as x approaches 4 from our left-hand side, and we're following this graph from the left-hand side, then at 4, we see our point is up here at 7. Whereas if we look at the limit as x approaches 4, and we're coming from the right-hand side, then you're following this part of the graph. And as I get close to 4, I notice my y value is at 3. So once again, the overall limit, if they say what is the limit as x approaches 4, period, not from the left or the right, it does not exist. Okay? Now, a very easy one, for example, let's say we did a limit as, see if I can find an exact point here on the graph. About right there. So if we said, let's look at the limit as x approaches -5. Well, if we come from the right-hand side, you'll notice that that point is at -4. If you come from the left-hand side, then again, that limit is at -4. So overall, we say the limit as x approaches -5, period, is -4. So you'll notice a difference that when we don't have breaks in the graph, that's typically when the limit exists. When we do have these breaks, you're going to have different one-sided limits like we saw, and then that's going to be when the overall limit does not exist.